In this video, let's build a Spring Boot REST API that applies filters to images that we're going to pass as input. The REST API we're going to build could be the foundation of your next portfolio project. Let's take a quick look at this diagram. So we're going to have an image filtering REST API that is going to take as input an image. We are then going to do some pixel manipulation, and then the user is going to get back an image with some filters applied. We're going to be implementing different filters, and I will show you the theory behind them as well. Before we start coding, I think it's important for you to understand how images work. If you were to take a magnifying glass and point it to your screen, you would see some blocks. These blocks are pixels, and these pixels compose your images on a digital screen. Each pixel can have a different value that goes from 0 to 255. 205 represents the maximum intensity, or in the case of a black and white image, it represents the color white, whilst 0 represents the absence of color, so in this case, black. And as you can see from this diagram, each image can be represented as a 2D matrix, and each matrix point corresponds to a pixel, and each pixel can have a different value that goes from 0 to 255. You might be wondering, how do colored images work? They work in a really similar way. The main difference there is that each pixel is composed of 3 colors: red, green, and blue. And each of those components can assume a different value going from 0 to 255. And using the same logic, we can also manipulate values in those pixels. I hope this quick recap about pixels was useful. Let's now move on to actually building our REST API. The first thing we want to do is go on Spring Initializer and let's create a new Spring Boot project. I'm going to be using Java, Maven, and Spring Boot 3.5.6. Let's give it a name, and I'm going to be using Java 17. The dependency you need to import here is Spring Web. Then let's press Generate and let's open the downloaded project in an IDE. I have opened the downloaded project in IntelliJ. And the first thing we need to do is go to the pom.xml file, and we need to add another dependency. This dependency is needed for image processing. So if you go down to dependencies, let's add a new one. And the new dependency we need is called Commons Imaging, and it's from the apache.commons. We're going to need this to actually be able to read images and create images. So let's do a Maven sync, and this should be imported into our project. The next thing we want to do is we want to create a new package where we're going to have our main controller. So let's create a controller package. In here, I'm going to create a new class called image controller. And this is going to be tagged as a REST controller. Let's also add a request mapping, which is going to be the base path of our endpoints. And I'll call it API v1 images. We are also going to need a service class, so let's create a new package called service, and let's create a new class called image processing service in this new package. Let's tag this as a service class. Let's go back to our controller. Let's inject the service class into the controller. So private final image processing service. Let's import the class and let's inject it into the constructor. So this is where we're actually going to start implementing the filters. So you might be wondering which filter we're going to be implementing first. And the first filter I want to implement is called the invert filter. Let me use Brilliant to show you how an invert filter actually works. I'm going to be using the programming with functions course. So if you go to filtering images, let's start and let's see how this filter looks like. So we've got an image of a dog. What we want to do is we want to set every pixel to 255 minus its current value. And this is going to apply the invert filter to our image. So as I said, each pixel is a value in a 2D matrix. We want to go through each pixel, and then for each pixel we want to do 255, which is the maximum, minus the pixel value. Let's check. And you can see we have applied an invert filter. If you want, you can also see Brilliant to see the explanation. We have assigned to each pixel its inverse by doing 255, which is the maximum value, minus the value of the pixel at that specific point in the grid. So you can go into the explanation and have a read if you want. Let's go back to our Spring Boot application and let's apply this invert filter. Let's do the actual implementation. So this is going to be a post endpoint and the value is going to be filter/invert. This is going to consume a media type which is called a multipart form value. What we're going to produce is a PNG image. We want to import this, so the import is not working. Let's see. Let me try a manual import. So if we go up here, so the manual import has worked. I don't know, for some reason IntelliJ was not able to detect it automatically. We want to return a response entity of type byte array, and we'll call this method invert filter. We are going to take as input a multipart file, which is going to be called image. This can throw a input-output exception. Let me just do some indentation. Let's import the response entity. In here now, we want to call the image processing service, and we're going to be creating a method called invert image. We are going to pass the input file, and as a result, we will get back a byte array, which we're going to return back in a response entity object. We'll send back an OK. And content type, this is going to be media type dot image PNG. And in the body, we are going to send the actual inverted image. So this is our controller done. Let's go to the image processing service. And in here, we now want to create a public method that returns an array of bytes. We'll call it invert image. As input, we're going to get a multipart file. We'll call it image file. This can throw an input-output exception. Okay, so this is where we want to do the actual invert filter. We first want to read the actual image and transform it into an array of pixels. Let's create a buffered image. This is going to be the original image. So let's import that. Original image. We want to read the multipart file using this image input-output class.read. Now, let's also create a new image for the inverted result. So this is going to be our output. We'll call this buffered image, inverted image equals to new buffered image, and is going to have the same size as the input file. As you can see, we are going to be handling RGB pixels. One pixel will have 3 components, red, green, and blue. So now we want to process each pixel. We want to use a nested for loop. As I said, an image is made of pixels, and pixels have a layout of a 2D matrix. We are going through each cell of the matrix, and we are going to get the original RGB value for that specific pixel, and then we are going to invert the RGB value for that specific pixel combination. And to invert, we are going to use a bitwise NOT operation. So it's a bit different to what we have seen on the example on Brilliant, but I wanted to show you this other example as well. But if you really wanted, you could just do 255 minus RGB, and this is exactly the same as the explanation on Brilliant. So it's really up to you. I think the bitwise operation is a bit more advanced, so I also wanted to show you this one, and I'll leave it here. So now we have inverted our image. What we want to do is convert this buffered image as an array of bytes. I'm going to do byte array output stream. image as bytes. So, and then we want to do image io.write inverted image. We are going to be inverting the image and write it to this output stream. And at the end, we can return this image byte array output stream dot to byte array. And here we go. We have written our first image filter. The next thing is to run this Spring Boot application and test if this filter actually works. So let's create a new configuration file. I'll call it image processing. By the way, I meant run configuration, not configuration file. So let's click apply. Okay, let's run this. So the application has started successfully. Let's remind ourselves of the base URL. So it's API v1 images/filter/invert. I'm going to be using Postman to send the requests. So it's going to be a post request going to HTTP localhost 8080 API v1 images filter/invert. And now to send an image as part of the request, go to body, click form data, and over here select file. Let's click new file from local machine. Select any image you want. So I've got an example image of Mark Zuckerberg. At the bottom of the screen you can see how this original image looks like. So let's send it to our REST API. We've got a bad request. Let's see what's happening. Required part image is not present. Okay. You want to also send a key called image because we have defined this parameter with a name image in our REST controller. So let's try again. And as you can see, this is the result. This is the inverted image where we have applied an invert filter. You can also try with a different image. So let me quickly show you. Let's try with some butterflies. And you can see this has been inverted as well. Orange is the opposite of blue and blue is the opposite of orange on the color wheel. So the invert filter is actually working as expected and it's working correctly. Let's now go back to Brilliant to see what's the next filter we are going to be implementing. So we have again the image of a dog. We want to apply a solarize filter. So we want to invert every pixel whose value is above 128. As I said, each pixel can have a value between 0 and 255. For each pixel, if the pixel value is above 128, we want to take that pixel and set it to 255 minus the value of the pixel. Let's see what happens. You can see this is a solarize filter applied to this dog image. We can also see the explanation. So for each pixel, only if the value is above 128, we replace that pixel with the inverse. Let's go to Spring Boot and let's implement the next REST endpoint for the new filter we're going to be implementing. So this is going to be called solarize. It's going to consume the same media type and produce the same media type as well. The response is also going to be the same. Actually, we can just copy this endpoint and modify the name of the method. So this is going to be a solarize filter. Let's just say image, so we don't have to be modifying it every time. And here we'll pass that image to a new method in the service class called solarize filter. Actually, solarize image, just for consistency. Let's go back to our service class and let's implement this new method. So very similar to what we have done earlier, we're going to be returning a byte array. It's going to call the solarize image. I'm just going to copy this part. We're not just wasting time here. Same thing as before. We want to read that image. I'm just reusing the code we had written earlier. The different thing this time is how we treat each pixel. So what we want to do is we want to take each color and we want to build a new color class from the original image and we want to get the current pixel. So this is going to provide us the three components RGB. We want to get the red component we want to get the green, and we want to get the blue. And for each of these components, we want to apply the solarize filter. What does that mean? It's literally what we just saw on Brilliant. We are going to build a private method called solarize component. This is going to take as input a int. So as we said, a pixel has a value from 0 to 255. And based on the value of the pixel, we are going to apply our formula. So there is an error, it looks like. Oh yeah, we don't have closing bracket for the 4, so that goes out. So this is going to apply the solarize filter to each component, the RGB components. Let's build a new color with the new components that we have just solarized. And then let's set the current pixel with the new color that has the solarize filter applied to each of its components. And once we have done that, we can literally just copy this. You might even want to just extract it into a method. Let's create a byte array output stream. And this time is the solarized image we want to return. This is all we need. So let's restart our Spring Boot application. Let's go back to Postman and let's go to the new filter URL, which is solarize. I'm gonna send the same butterfly image as input. And as you can see, this time this is the output for solarize. Let's also try with the other image of our friend Zach. And here is a solarized image. You can see this looks very similar to online services that provide a way to apply filters to images. And literally, if you wanted, you could expand this project and just deploy it online and get people to pay to use this service. So this is another filter complete. Let's now move on to the next filter, which is called a clip filter. So let's jump into the next lesson on Brilliant to understand this new filter we are going to be implementing in our Spring Boot application. So let's go to our next lesson. We can see a clip filter works like this. If a pixel is below the value of 50, we want to set it to 50. So basically we are bringing up the value of low pixels. Low pixel means dark pixel. We're actually bringing the brightness a bit up. For each pixel, if the pixel is less than 50, we want to set that pixel value to 50. And we can see this is how a clip filter works. Let's now go back to our Spring Boot application and let's implement this. So let's stop our Spring Boot app. The same way we have created these endpoints, we want to add a new endpoint called filter clip. So it's literally the same thing, just has a different name and it calls a different method in the service class. So I've just done a copy and paste. Let's create this clip image method inside the service class. It's going to be very similar to what we have already done before. So I'm going to spare you the boring parts which we have already explained. So let's create a new method called clip image. In this method, let's read that input file using a buffered image. And then we want to do a for loop. We want to actually do a nested for loop because it's a 2D matrix. And then we want to get each of the components of the color as we did before. In the same way, we want to get the red component and we're going to be applying a clip filter. So component get red, the same for the green and same for the blue. Now we also want to create this method which I'm going to call clip component, and it's going to be very simple. It's going to take as input the pixel value, and then if the value is less than 50, actually this suggestion by Copilot is wrong. Yeah, that's why we need to be careful with AI. So what we want is actually math.max between 50 and component. This is another way of doing that if condition. So we can simply take the maximum. If component is less than 50, we're gonna just take 50. We are going to have each component of our RGB clip in this case. And then we can simply just save this new color to the current pixel value in the new image using the same logic we used earlier. And then we can simply return the byte of arrays, which is going to be our new clip image. This is what we need to create a clip filter. Let's run it. Let's go to Postman, and let's call this clip filter. Let's use Mark's image, and you can see it's actually looking similar to what we saw in Brilliant. As you can see, these images are very similar to each other because we have used the same logic. Let me also show you how this looks like with the butterfly images. So this is a different image I've used. I don't think it makes it justice, so let's go back to our other image of butterflies. And yeah, we can see this kind of dusky filter applied to this image. And this is another filter we have implemented, and we have expanded our REST API offering. Let's now move on to the next filter. Let's go back to Brilliant to see the next filter we're going to be implementing. So let's look at this image. In this case, we can see we have multiple criteria to follow for this filter. So I'm gonna call this a custom filter. We want to increase low pixels by 50 and decrease high pixels by 30. I guess this is kinda gonna smooth out the image. So let's see how this looks like in action. We want to check if pixel is less than 60. So this is going to represent the low pixels. We want to increase the value by 50. And if the pixels are greater than 200, we want to decrease by 30. And yeah, you can see it has kind of smoothed out the image. It's a bit more blended. We can also see the reason why. You can see Brilliant is actually very useful in understanding concepts in a really fun way and in an engaging way. So we have finished this lesson. We can now go to our Spring Boot application and implement this custom filter. So let's stop this. Let's go back to our image controller and let's add a new endpoint. So let me just fix the indentation. Same as before, we are just going to have a new URL, a new method name, and a new method we're going to call in the image processing service class. Over here, same as before, the initial part is going to be very similar to the clip image. So let me just copy this because it's gonna save us a lot of time. We just want to change the name and call it apply custom filter. We still want this for loop. This time we want to change the name. We don't want to call it clipped image, but I'll call it filtered image. By the way, you can see there is a lot of repeated code. Feel free to refactor this and make it look nicer. Here we want to apply a custom filter component to each of the RGB component of our pixel. In this case, we're going to create a new private method. I'm going to call it custom filter component, and we are simply going to have the if-else conditions we saw on Brilliant. If the component is less than 60, we're just gonna increase it by 50. And we're going to make sure by using the math.min that we don't exceed 255. Otherwise, it's a high pixel. In that case, we subtract 30, but we also want to make sure that we don't go below 0. And once we've done this, we just return the component. We build an output image of kind byte array output stream. And we are going to have an image with an applied custom filter. I want to add, if you really want, you can also give the possibility to the user to send some extra parameters, which are those values, the high pixels and the low pixel value, so they can customize it a little bit. In this case, I've left it for you as an exercise. So let's start our application. Let's go to Postman and let's apply this custom filter. Let's click send. And as you can see, the result is different. Let's try with our friend's image. And this is how it looks like. You can see this weird effect on the skin. But yeah, feel free to play with these values. We have applied another filter, but I still want to show you another one, which is quite important and also the foundation of image filtering, which is the brightness filter. Let's go back to Brilliant to see how the brightness filter is going to work. So let's go to the next lesson. Let's start. Let's see how the brighten function should work. This brighten function should increase the pixels by a value of 20, but we have to make sure to not go above 255. So we already saw how to do that in Java. Let's solve this. And let's now go to Spring Boot and implement this function in our REST API. So very similar to what we've done earlier. Let's add a new endpoint, which is again going to be a post endpoint. It's simply going to have a different URL and it's going to call a different method in the service class, this time called Brighten Image. So let's go to our service class. I'm going to just give you the code because I feel like we are just repeating some of the things. The main thing you have to notice is these 3 lines. We are basically using a math.min. We are just doing color.getRed plus 20 and we get the minimum. If let's say this was to go to 270, that's not valid. So we would just be setting the red to 255, which is the maximum. Literally, that's how we apply a Brighten image filter. Before showing you how this one works, I also want to give you a bonus filter, and that's the black and white filter. Let me show you how this filter works. So if you go back to Brilliant, we have another lesson that is going to show us how this works. Basically, we are going to first brighten each pixel, and then we're going to turn dark pixels light and vice versa. To show how this is going to look in pseudocode, basically for each pixel, we're going to brighten the pixel. And then for each pixel, we're going to have a black and white method. And that's going to determine if the pixel is gonna become black or white. This is the output we expect from a black and white filter applied. So if you go back to our Spring Boot app, let's also create a new controller for the black and white. And I think that's quite interesting. So if we go here at the bottom, let's create a new REST endpoint. And let's implement this black and white image method in our image processing service. So the initial part is very similar to what we have done for other images. The interesting part comes now. So we're going to first implement brightening, which is going to be the same as what we have implemented for the brighten filter. So literally we just increase the brightness of each component by 20. Then we want to have another pass over these pixels. You could also do it in the same one. To be honest, you don't need a second pass, but just for clarity, I'm gonna have it separate. And there is a bit of technicality involved, but I feel like you don't really need to know this. But basically, we calculate the brightness using this formula that uses each RGB component with a constant applied to it. Once we have the brightness, we check if the brightness is above 128, we set it to white, which is 255. Otherwise, we set it to 0. And then we save that in our new image, which is the black and white image. We are then going to return a byte array as a response. So if we run this, let me quickly show you the brighten image filter first. So again, let's use Mark's image, and this is the brighten image. And let's go to the more interesting black and white. And we can see we've got a black and white image. Let me also show you the one with the butterflies. So you can see the colored butterflies, they became black and white. And here we go, we have built a REST API that processes images. You can now go and use this as the base of your next portfolio project. You can go and add more REST endpoints or more complicated filters. You can even go and make this an actual app that you're gonna charge people to use, or maybe you can just use it for fun. This is really up to you. I want to also suggest Brilliant. They've got hundreds of courses which are also focused on different topics such as foundational math, programming, computer science, data analysis, AI, and many other interesting topics which are going to be really useful for your learning. If you want to check out Brilliant, don't forget to use the link you see on the screen. I hope you found the video interesting and useful. Let me know your thoughts in the comment box below.